On completion, Turkey's 1915 Çanakkale Bridge will be the longest span suspension bridge in the world, 4.6 kilometres long, with a central span of more than 2 kilometres. Supported by 318-metre high bridge towers, it will connect Gallipoli on the European side of Turkey with Lepseki on the Asian side. On a project of this scale, the engineering feats are staggering, and so are the heavy lifting requirements. That's why, when the joint venture partners, DLSY, won the contract to construct the bridge, they turned to the men from Mars for help.
The engineering feats on this project they're amazing, and I think for us to get involved so early on in the design of a solution to suit what our client was trying to achieve was really the key to the success of this project. We got involved very early during the design. We were working directly with our client, and together we were developing a solution that we knew would work and was meeting all the requirements of what our client was trying to achieve, which was really about driving down the program time, reducing cost and increasing safety on the project. When they first approached us, they had a methodology which was based on current technology that they knew was available in the market, and we took that away and we said, you know, using our technology, our cranes, our specially designed cranes, you can reduce the amount of lifting that you're doing on the project. So we took what they'd originally planned as being 8 lifts to put a section of the bridge up. We took that and did it in 1 lift.
Using 2 of our MAR 2480D heavy lift luffing tower cranes, each with a lifting capacity of 330 tonnes, our solution allowed large modularised sections of the bridge towers to be fabricated in a controlled environment off-site before being delivered to the worksite for installation. This helped to de-risk the project by taking the fabrication and associated construction tolerances off critical path. The 2 M2480Ds were shipped from Australia to Turkey via Singapore. And in a combined global effort with our engineers from Australia, the UK and Middle East working together, we fabricated specialised equipment for the project in our Middle Eastern fabrication facility. Our first milestone on the project was to assemble both cranes on purpose-built quayside foundations. After building the 300-tonne grillages, the next job was to lift them from the quayside and install them at the bridgework front. Using the 2,200-tonne capacity TAC Lift 4 floating heavy barge crane, the cranes, each weighing 600 tonnes, were lifted from the quayside and transported to the work sites a kilometre offshore on the Çanakkale Strait. It was the first of 2 world-first engineering feats on the project. After climbing the cranes to their final height of 328 metres, the next major milestone was the installation of the upper crossbeam. With the M2480D positioned 328 metres above the water, it took approximately 30 minutes and a lot of planning to lift the 155-tonne section into position and create a new world record for the heaviest lift at height.
From an engineering point of view, the job was a massive challenge, which we love. Earthquakes, high wind, water, and how to keep up with a huge program. But we solved it with the right combination of craneage, people, and teamwork.
After successfully completing the construction of the bridge towers, the M2480Ds were climbed down the completed bridge towers and safely recovered.
I think if you look at how bridges in particular have been built in the past and continue to be built around the world now, and you look at what we have done at Chinacoli, you'll see that it's completely different. It's a game changer for the industry. And I think it really sets the tone going forward about now what's possible.